All right, hey fifth graders, we are going to go ahead and extend and talk about multiplying decimals by decimals. Thankfully, our process does not change. We are concerned about how many decimal place values our factors have, or the numbers we're multiplying. We're going to do our little dippity-doo-dah strategy. But I want to talk about why we do that. So I know that you boys and girls can do a good job remembering how to do those dippity-doo-dahs, but again, I'm more concerned about why does that work. So I'm going to kind of guide you through some discovery here, and I think we're going to make some major conclusions at the end. That's pretty cool. So we know our powers of 10. We did a lot of place value work at the beginning of the school year. So what's 10 times 10? I know 10 times 10 is 100. And I know 10 times 100, I'm going to tack on a 0 to that. That's 1,000. And 100 times 100, I have 4 total zeros. That's 10,000. Okay? So we can use our whole number knowledge and extend that to our decimals. So let's go ahead and instead of thinking about 10, let's think about 1/10. So let's write that as a decimal and as a fraction. 1/10 is going to be 1 sitting in the 10th place value. So that's 0.1, 1/10. And then as a fraction, it is 1 over 10. Okay? So if we are now talking about decimals, where I'm multiplying decimals by decimals, let's go ahead and think. What would a 10th times a 10th equal? So I'm already kind of in my brain thinking about, well, maybe what is 10 times 10 equal? And that might be helpful. Let's see. So let's actually go ahead and write this as a fraction and see what happens. Now I know we did not learn how to multiply fractions yet, but this is going to be, it is very easy, and I'm going to go ahead and just kind of tell you how to do it, and we are going to draw a really nice conclusion. When you multiply fractions, you multiply the numerators on the top, and then you multiply the denominators on the bottom. You just multiply straight across. You multiply straight across. It's really, really nice. So if I'm multiplying 1/10 by 1/10, well, I get 1/100th. Interesting. 10 times 10 was 100. A 10th times a 10th gave us 100th. Interesting. Let's take a look at another example. Let's talk about a 10th times 100th. Well, 10 times 100 is 1,000, so I'm thinking maybe this might be 1,000th. Let's see. Let's multiply straight across, and we get 1 over 10 times 100 is 1,000. We get 1,000th. Just like, again, just with our whole numbers, let's make a connection to our whole numbers. 10 times 100 was 1,000. Well, a 10th times 100th is 1,000th. That is a very nice relationship right there. And lastly, let's look at 100th times 100th. Well, I know 100 times 100 was 10,000, so I'm assuming this will be 10,000ths. And it is indeed, because 1 times 1 is 1, 100 times 100 is 10,000, so that is 1/10,000th. So let's take a look. So if we multiply a decimal by a decimal, 0.1 times 0.1, 1/10 times 1/10, we get 1/100th. Now notice, I have 1 decimal place value, 1 decimal place value, and my final answer had 2 decimal place values. 1/10 times 100th, well, we got right up here, we got 1,000th. Let's look at the number of decimal place values we have. 1, 2, 3, 1, 2, 3. Now we already proved mathematically what we get and why we get it. We're using our place values. And lastly, we have 1/100th times 1/100th. We got 1/10,000th, tenths, hundredths, thousandths, 1/10,000th. Let's look here. I have 1, 2, 3, 4 decimal place values, and I had 4 decimal place values. So this really explains in general why we do this method, this dippity-doo-dah method, where we count up our decimal place values. It's not just because somebody decided, hey, let's just count up all the decimal place values and call it a day. No, it's because mathematically there's a lot going on. Because mathematically, a 10th times a tenth sorry boys and girls, I had a low battery notice come on my phone. A tenth times a tenth is a hundredth, and so that's why it had 2 decimal place values. A tenth times a hundredth is a thousandth, which is why it has 3. So in general, a tenth times a tenth is a hundredth. A tenth times a hundredth is a thousandth. And a hundredth times a hundredth is a 10,000th. Let me go ahead and plug my phone in here so I don't lose you guys. All right, let's see if that works. You'll just have to kind of ignore the cord for me. I apologize. All right, so let's go ahead and press on. And let's talk about multiplying these decimals now. So now that we have a good idea of why we end up having, why we count up all those decimal place values, let's go ahead and summarize that. So in general, when we're multiplying our decimals, we're going to multiply just like we do with whole numbers. Okay, so we're just going to go ahead and multiply. Here's the important part. At the end, we are going to add up the total number of decimal place values between our 2 factors. And that's the amount of decimal place values that our final product or answer will have. It's suggested that you put the factor with less digits on the bottom and shift it all the way to the right. This is something we talked about when we were multiplying our decimals by whole numbers. And remember, your decimals do not need to be lined up. In fact, it's easier if you don't line them up. So let's go ahead and model what's happening when we're multiplying decimals. So I'm going to multiply 4/10 by 2/10. This is a really nice strategy that provides a visual as to why we get the answers that we get. Let me grab a pencil here. So 4/10, I'm going to go ahead and shade 4/10 vertically. So that's 1/10, 2/10, 3/10, 4/10. Now I'm going to multiply that by 2/10. So the way I can do this is just a really nice method that you boys and girls can use, but I don't think it's the most straightforward method or quickest method. Now I'm going to shade in 2/10 in the opposite direction. 1/10, 2/10. 2 of these strips. Your product is where they overlap. So let's go ahead and count how many boxes those are. So we have 8 of those tiny squares, and how many total are there? 100. That is 8/100ths. And as we're going to learn, and you know what, let's go ahead and do the multiplication. So I have 4/10 times 2/10. Okay, let's count up our decimal place values. 1, 2, 1, 2. So that is, we got the same exact answer, 8/100ths, and that's just a nice visual for you. Let's do this method again. 5/10 times 3/10. So I'm going to go ahead and shade in 5/10 vertically. 3, 4, 5. And horizontally, I'm going to shade in 3/10. 1, 2, 3. Where they cross is the product. There's 15/100ths. 15 of these little boxes out of 100, 15/100ths. Let's go ahead and do the multiplication. 5/10 times 3/10. I have 2 decimal place values, 1, 2, 1, 2. I also get 15/100ths. Let's do a few more examples together where we just use our algorithm, where we're not modeling, but we're just doing the problems. 2 and 5/10 times 6 and 7/10. I'm going to get this cord out of here now. Hopefully that's enough. 2 and 5/10 times 6 and 7/10. I'm going to ignore the decimals, and I'm going to multiply these as if it was 25 times 67. So I'm going to start my ones digits, or excuse me, tenths here in this case. So that's 35. 14 plus 3 is 17. Now when I move over here, I need a 0 placeholder. Just like we did when we multiplied multi-digit numbers, 2-digit numbers. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15. I add them, 5, 7, 6, 1. Now I need to count up my total place values. 1, 2, 1, 2. 16 and 75 hundredths. Now let's go ahead and make sure this sounds reasonable. So this is approximately 3, that's about 3 times about 7. 3 times 7 is 21. I got 16. Not super duper close, but that's because we rounded both of these up. So it's an overestimate. 21's an overestimate. That's under 21, so I'm feeling good about it. 4 tenths times 8 and 32 hundredths. Again, put the one with less digits on the bottom. That's 8, 12, 33. I don't need to multiply those zeros throughout. 1, 2, 3, 1, 2, 3. 3 and 328 thousandths. So here I have 2 decimal places. Here I have 1 decimal place. So this will have 3 decimal places. DP is decimal places. Let's go ahead and do 1 and 21 hundredths times 2 and 3 tenths. 3, 6, 3, 0 placeholder. 2, 4, 2. I'm going to add these together. 3, 8, 7, 2. And I'm going to add up my total place values. 1, 2, 3, 1, 2, 3. 2 and, 2 and 783 thousandths. And our last example together, 0 and 917 thousandths times 6 tenths. I'm going to go ahead and multiply normally. I'm going to ignore the decimals till the end. 2 carry the 4, that's going to be 10. That's 54 plus 1 is 55. That's a 5. Let's see how many total place values I have. 1, 2, 3, 4. 1, 2, 3, 4. Do me a favor and throw a 0 out in front. 0 and 5,502 10 thousandths.